Hi students, today we are going to discuss the paper 4 Theory Physics IGCSE 0625 Feb March 2025 paper. Okay, so let's start. The first question is given that this is a graph which shows a force extension graph. You can see here in x-axis we have extension and y-axis we have a force in Newton, right? What is the first question is given? Given that calculate the spring constant K of the spring. So this is a question of Hooke's law. So if you see the question belongs to the formula that is F equals to Kx. You can see here, right? So F is the force and X is the extension in spring. So if I try to find out the value of K, if you rearrange it, if I take this X to other side, it will be F over X, right? So we have to get the value of F and X from the graph only. If you see here, you can take multiple values. Okay, for example, now if I say here this is X equals to given that is extension, that is 0 0.02. So at that time we can take force equals to 1000, because if you draw a vertical line to the graph, this will if you draw the parallel line to the like x-axis, you will be getting this is force and this will be your X. Are you getting it? You can take these two values, or you can take these two values, or you can take these two values. Your choice, doesn't matter, you'll get the same answer for this question, right? So like that, for this question I have taken, so for example, force equals to 2000 and X equals to, I have taken 0 0.04, which is extension spring. When you put it, I'm getting 50,000. So up to a significant figure, I got this K equals to 50,000 Newton per meter. So don't forget to write the unit for this, is very important. So it is Newton per meter. Got it? Right. Next question is given. A student states that spring has not reached the limit of proportionality when a force of 4500 is applied to it. Try to understand that what do you mean by limit of proportionality. For example, if I draw a graph like this, okay, so if I this is extension in spring and this is a force in the spring, right? So if the curve is looking like this, you can see here this point will be known as the limit of proportionality. Why? Because up to this point, from here to here, this X and F varies directly proportional. After P, like right after P, limit of proportionality, it doesn't vary what, directly proportional. Got it? So but in this case, as per the question, what is given that the force of 4500 Newton applied to it. Let me check here. So this is 4500. When I try to draw a parallel line to this one, it meets here. After this is also a straight line, right? That means after 4500 also, this extension in x-axis and force in y-axis, we have a straight line. That means this is directly proportional to each other. That's why we can say that at 4005 Newton, X means extension in spring is still directly proportional to force, and it is a straight line. That means it is obeying the Hooke's law. Got it, everyone? Right? So if I'm going fast, just pause it or write down, or you can just visit my website www.mathtonic.com and download this worked solution from my website. Okay, next question number C. The springs can be compressed by forces. The spring described in this figure, is talking about the graph, is compressed by force F and an extension of negative 0.025. So the formula determine the F. So F equals to Kx. Already we have done the Hooke's law. So as per the question, the previous part we got F equals to, what is the force we got? 50,000 Newton per meter, right? Right? Yes, here. So in place of K, I am putting here 50,000. X is given already, negative 0.025. Remember this negative sign. Why? This negative sign used for that you are compressing instead of pulling, right? For example, we have a spring like this. If you're expanding, it will be positive. If you are compressing, it will be negative. Got it? So it is moving in opposite direction. That's why we are getting the answer in terms of negative. So negative 1250 Newton, that is a force due to the compression, that is negative 0.025, and K already we got 50,000. If you know times it, we'll get the answer. Question that D, whether force is a scalar quantity or a vector quantity. This is easy because we know that force is a vector quantity. Why? Because it has both magnitude and direction. Okay. Next, move to question number 2. Question number 2 is given that there's two trolleys. You can see here, this is trolley A, this is trolley B, and this bench is frictionless. There is no friction, right? Trolley A moves to the right. It is moving like this with a constant velocity u equals to 0.44 meter per second. That means the speed of trolley A, I have written here u equals to 0.44 meter per second. And trolley B, that is stationary, that means the velocity of the trolley B equals to 0 meter per second. Got it? Figure 2.1, trolley A, before it collides, this is trolley B, and this is directional motion is given. Question is given that state the momentum of trolley B before its collision. It's okay, very good, because we know that momentum will be 0. Why? Because we know momentum equals to mass time velocity, and for trolley B, what is the velocity we have? 0. So mass times 0, that is momentum equals to 0. Easy. So I have written here already momentum 0. Why? Because trolley B is at rest, u equals to 0. So mass time velocity, if you replace this, I am getting momentum equals to 0. Got it? Next is, after the collision, the two trolleys are joined together and traveled with a constant velocity, that is 0.18 meter per second to the right. The mass of trolley A is given 0.75 kg, and we need to find out the mass of trolley B. Listen carefully. Here, this is a trolley, we have trolley A, and this is a trolley B we have, right? After collision, what happened? This trolley A and trolley B, okay, simultaneously they are moving in a constant velocity, both, correct? So this we have a mass of trolley A, then we have a speed of trolley A as well, we have a mass of trolley B, we have a speed of trolley B as well, right? But after collision, what happens? They are moving in same or constant velocity. Did you get it what I'm trying to say? If you remember, we have to apply here the, see, I have written the notes as well so that it will help you in the other questions when you solve it, right? So this question is based on principle of conservation of momentum. What says that momentum before collision equals to momentum after collision. What is the momentum formula? I told you right now, that is P is the momentum and P equals to mv, right? So momentum before collision means, what the formula says, that trolley momentum in trolley A plus momentum in trolley B, that equals to after collision, that is ma plus mb times b. Why? Because this v is two trolleys moves in constant speed. That's why. Got it? If they would have gone in different speeds, then I would have written MAVA plus MVVB in that case, right? So now simply mass of trolley A is given 0.75, speed of trolley A is given 0.44. Before collision, we got to know that this momentum of trolley B equals to 0, and mass A plus mass B, because they are joined together, they're like a single system, and times the single speed is given 0.18, right? So when you do this, I got 0.33, I think, right? And 0.33 over 0.18, this one, and this is 0.75, right? This is MB. We got it, right? Because this 0.18, if I try to move it, it will go down to the denominator, and if you rearrange it, I am getting MB equals to 1.083 kg. Be careful whenever you are writing, the unit as well, right? And up to two significant figure, we got this as a 1.1 kg. I hope you understood this question, right? Done. Go to the next part. Question C. The trolleys move onto a rough surface, right, which exerts a constant force on trolleys and brings them to rest. It is 2.6 seconds. What does it mean? They were moving, right, and bring them to rest. That is what? 2.6 seconds, right? So this is a question, calculate force. This is a question of impulse. This is an important question. Remember, impulse equals to force times change in time. The delta t means change in time. So change in time means, see, it was moving and come to rest, right? So change in time is given 2.6 seconds. Do you get it? There is one more formula, that is impulse is equals to momentum as well. Are you getting what I'm trying to say? So impulse equals to momentum as well. So I can say, so F times change in time equals to change in momentum. Correct? So I've written here F times delta t equals to delta P. So F times delta T equals to change in momentum will be mb minus mu, and we know that they are moving in single like system, and they have m total mass, right? So m equals to v minus u. So F equals to mv over delta T. If you rearrange it, what is the total mass we have for two systems? 0.75 plus 1.08. Their velocity is given 0. Constant velocity is given 0.18, because in this case two trolleys are moving in constant velocity after collision. And what is change in time is given 2.6. If you put it the value, you will get 0.127 Newton. Up to two significant figure, it will be 0.13 Newton as well. Got it? The question comes, a different rough surface exerts a smaller resistive force on the trolleys, and state how this affects the time taken to bring the trolleys to the rest. Expression. Answer. Very simple. I told you already that F equals to, that is momentum, right? mb over T, right? Now F is indirectly proportional to time. If force decreases, time increases. Got it? So obviously, even when you are putting a small resistive force, that means you are decreasing the force, so time will increase. The statement I have written, time increases. Due to, what is explanation I have taken? Due to smaller resistive force, this causes a smaller deceleration. Yes, and it takes longer time to reduce the velocity to become 0. Got it? So yes, this is the answer for this question. I hope you understand. Okay, so again I'm saying you can visit my website www.mathlearning.com, from where you can download this that worked solution of this paper. Okay, so by that time, please subscribe and share this video to your friends, so that you can get regular physics maths videos regularly. Okay, next. Yes, this question number 3 is given that this figure shows electric heater used to heat a small room, right? You can see here. So this two are given heating elements, and this is shiny metal surface. State the region of electromagnetic spectrum which radiates thermal energy from the heater. See, you should know the notes that infrared is used for electric grills, remote control, optical fiber, thermal imaging cable TV, right? So definitely this is will be, the answer should be infrared radiation. Got it? Now question is given that explain why the shiny metal surface behind the heating elements increases the thermal energy radiated into the room. See, for this we have to remember this one, the how the effect of surface color, right, happens. So if you see this shiny, for shiny silver color, there is absorbing power is the worst, and reflecting power is a what, best. For matte black, absorbing power is the best, and reflecting power is the worst, and best is the emitting power as well. So you have to remember this thing. So that's why I've written for the notes, right? You can remember for other questions as well. So what is the answer for this? Because shiny surface are not able to absorb the heat. Yes or no? Right? I've written here shiny surface is very worst in absorbing, and they are best at reflecting heat. They are best at reflecting heat. Got it? Now, the metal outer casing of heater is earth. State why this is important safety feature. So I've written the answer. Please pause and write down. In case of live wire comes in contact with casing, earth wire provides a low resistance path for electric current, okay, to flow to the ground, which causes a large current to flow and trips the fuse and circuit breaker. I hope you know what is fuse and circuit breaker. I've written the definition for that also. What is fuse? A wire which melts if the current is too high. And what is circuit breaker? A device which stops the current flowing in a circuit when current is too high. So please pause it and write the answer. If you don't understand, please pause it again and try to understand this. Got it? So this is the answer, question number 3. Next, question number D. The main voltage is given 230 volt. The two identical heating elements are connected in parallel. Each heating element has a resistance of 89 ohm, right? Calculate the current in one heating element. Try to understand this. So I have just drawn this figure for your understanding purpose. What is the question is all about? You are giving the voltage 230 volt. You can see here we have two heating element, each of 89 ohm, and they are connected in parallel. These are the parallel connections, right? So question is given, what amount of current will be flowing in this one heating element? And yes, we can use the Ohm's law. And you should know that when the elements are connected in parallel, so voltage is same throughout a parallel circuit. Got it? This voltage will be, see, the voltage will be exactly same through the parallel circuit. So Ohm's law says that V equals to I times R. So we need to find the value of I, rearrange it. I equals to V over R. So voltage is given 230 and the resistance of the heating element is given 89 ohm. If you divide this, you are getting 2.6 ampere. Be careful. Please write down the unit of this current is equals to ampere. Got it? So this is this element will have 2.6 ampere, right? And for this also I'll be getting 2.6 ampere, correct? Now show that the electrical power of a heater is approximately 1200 watt, 1200, and state any equation you use to in words or symbols, right? So see, what the question is about, we need to find out the power in that, right? So P equals to VI, or current times what I can say, the voltage. Now question is that what will be the current in case, so be careful, in this single element we got this current as a 2.6 ampere. What does it mean? That means from this connecting point this amount of current is flowing in this line. Do you understand what I'm trying to say? What does it mean is, that means this current is exactly halved into two circuits. This is also 2.6 and this is also 2.6 ampere, because each element will get the same current, right? Correct? Now then what is the total current for this case will be careful. So you have to write down that is 2.6 times 2, that equals to 5.2 ampere will be the total current in the circuit. So when you're trying to find the power, P equals to IV, P equals to 5.2 ampere, V equals to 230 volt. When you put it, you'll get 1186.8, and up to like two significant figure, your answer should be 1200 watt. And be careful, so please write down the unit also, that is P equals to 1200 watt. Got it? Yes. Next question is, the heater is 95% efficient at converting electrical work done to thermal energy, right? Calculate the thermal energy emitted by heater in d double in 60 seconds. Give an answer, two significant figure. Try to understand this. Power is nothing but that is called the work done, right? And we know that work done equals to that how much of energy is transferred per second. See, this what I can say, this watt can be written 1200, that is joule per second. Yes or no? This is for 1 second, right? But this thing is given, that is time is given 60 seconds. So 1200 joule per second times 60 seconds, we got 72,000 joule. This is the total amount of what I can say work done, right? But the efficient is given 95%, that means some loss is there. So 95 efficiency means multiplier will be 0.95. So 72,000 times 0.95, I am getting 68,400 joule. Okay, and up to two significant figure, my answer should be 68,000 joule. And in standard form we can write down 6.8 times 10 power 4 joule. Any one you can write and get the marks for that. Okay, I hope you understood this question as well. Question number 4. Question number 4 is given, a train has a maximum speed of 200 km per hour. It accelerates see from rest. From rest means what? Initial velocity equals to 0 with constant acceleration, that is 0.70 meter per second square. So this is a definition question. What is acceleration? Change in velocity per unit time. That is known as acceleration, change in velocity per unit time. If you remember, in y-axis I'll keep v, in x-axis I'll keep time. The gradient of v and t will be known as acceleration. So change in velocity over change in time will be known as acceleration. Show that the maximum speed of the train is approximately 56 meter per second. Right now I told you that 200 kilometer per hour speed is given, right? I need to convert this into meter per second only. That is the case. So how to convert kilometer to meter? It is 1 kilometer 1000 meters, and 1 hour equals to 3600 seconds. So what I'm getting is 55.55, which is equals to 56 meter per second, up to two significant figure. This is a simple question because when you convert this kilometer per hour to meter per second. Right. Next part is given, Calculate the time taken for a train to reach its maximum speed. Easy. So we know that acceleration equals to, that is velocity over time or speed over time or change in speed over time, right? That is the gradient formula. So a is given 0 0.7. So initial speed was 0, because if you read the question carefully, this is from rest, right? So u equals to 0. So v equals to 56 over t. The question is given, find the time, rearrange it. So 0. If you take rearrange it, 0 0.7 times t equals to 56. So t equals to 56 over 0 0.7. So we got this answer, that is equals to 80 seconds. Okay, next question. The train has total mass of 440,000 kg. Calculate the force which causes the acceleration of the train. So that is one formula, force equals to mass time acceleration, 440,000 times 0 0.7, and this answer should be 308,000. And yes, please write down the unit of this force, which is equals to Newton. Correct? Okay, the train travels into a headwind. The force of this headwind opposes the motion of train. State and explain the effect of this force of this on the motion of the train. Try to understand this one. If I say this is a train we have, and some force of headwind opposes the motion, what does it mean? That means the train will start deceleration, the speed will decrease. So that's why I written here deceleration, right? Explanation: what? The force of the headwind opposes the motion of the train, so it acts as a resistive force. Whenever resistive force is there, definitely there will be deceleration. Okay, next, question number 5. A light dependent resistor LDR has a low resistance in high light intensity and high resistance in the dark. Okay, so sketch the graph between the resistance we have to keep in y-axis and light intensity we have to keep in x-axis for an LDR. Remember, there are 4 types of resistors. One is fixed resistors, light dependent resistor, thermistor, and variable resistor. Got it? For fixed resistor, remember, for fixed and variable resistor, right, the light intensity and the resistance are directly proportional. That's what I've written here, right? For LDR, if intensity of a light increases, then resistance will decrease, right? Which is in thermistor, if temperature increases, resistance will be decreased. So in these two cases, okay, the two parameters will be inversely proportional. So question is given that for LDR, definitely I'm keeping, as per the question, resistance in y-axis and light intensity in x-axis. So this graph will looking like this, because this will be inversely proportional graph. Because at see, this is a maximum value of x, right? That is light intensity, right? This is a minimum value of what? Resistance. This is a minimum value of light intensity. So this is a maximum value of resistance. This is how the graph will look like. Next, figure 5.1 shows that the part of electric circuit used to turn on a light when it is dark, right? So yes, dark. So remember, when it is dark means LDR receives low intensity. Obviously there is dark means no light, less light, low intensity of a light, which results high resistance. That means if light decreases, intensity of light decreases, then resistance increases. So complete the circuit with a symbol of light dependent resistor. So remember, this is how we have to draw the light dependent resistor. You have to remember this, okay? Because light dependent resistor normally look like this. Okay, yes. Explain why the lamp is off in the light and lamp is on the dark. Use ideas about the potential difference in this one. See, question is given that we have to explain that why lamp is off in the light, okay, and lamp is on in the dark. Use the idea about the potential difference. Listen carefully. In the light, I've written here, in the light what happens? The resistance of the LDR is low, okay. Most of the potential difference is across the fixed resistor, therefore the lamp gets lower potential difference, so lamp is off. Try to understand this. For example, I'm giving the potential difference is 50 volt, correct, and this is in series, right? So definitely this will be, the potential difference will be there. It's not exactly same. For example, I'm saying, for example, if I'm saying this is getting 40 volt and this one is getting 10 volt, right? If this is 10 volt, this LDR and this lamp are connected in parallel, right? If it is consuming 10 volt of potential difference, this also be consuming 10 volt of potential difference. You understand what I'm trying to say? So in the light, what happens? The resistance of this increases, right? That means all the potential difference will be given to the fixed resistors. If the voltage is low here, potential difference PD is low here, the lamp also will not glow properly, or lamp is off. Do you understand clearly? Now reverse the case. Now for example, this one is 10 volt and this will be 40 volt right now, so this will get 40 volt as well. So this LDR and the lamp are connected in parallel. That means they will consume the same amount of voltage or PD, right? That means at the time in the dark, the resistance of LDR increases and most of the potential difference is now across LDR. The lamp gets a higher PD to turns on. So please pause it and write down the answer for this question. This is how you write down and you will get the marks in the exam. Okay. Next part. Question number 6. Figure shows the object which is 5 centimeter away from the center of the thin. See, center of the thin is here. You can just yes, this length is given 5 centimeter. This is called converging lens. So converging lens is looking like this, right? The focal length of L is given 3 centimeter. What do you mean by focal length? Focal length is the distance between the center of lens and the focal point. This distance is given 3 centimeter. Can you see this? So this is normally written as a F, but the question paper is what write down as a X. I'll tell you how. Yes, so you have to draw this. Okay. So we have drawn this one. Now first question is given, level the principal axis P. So this line is the principal axis, this one principal axis, this is P, right? On the place the letter X at the focal point. I told you right now, focal point means this is the center to this focal length is given L. No, this 3 centimeter. To measure this 3 centimeter, this will be a focal point F, but for this case the question is given X. Write down X here. Now draw two rays from O to locate the tip of the image produced by the lens. Very simple question. So this is the tip of the lens, right? Tip of lens, draw a parallel line to this one, center of this lens. Then this line or this ray will pass through the focal point. You can see here, right? One more ray will pass through the center of this one, like, and it will intersect this point at this point, right? And this point, it will be the image created at the right hand side of this one. Can you see this? Okay. Next part is given that the table place a tick right hand column next to all the three terms that describe the image in this one. Okay, listen carefully. If you see this, in a converging lens, if your image is produced in right hand side, this will be what kind of image? You can see here, this will be inverted image. What image? Inverted image. Got it? And this will be real image, and you can see here this is enlarged one as well. So yes, this is enlarged, this is inverted, and this is real image. If the image would have been created left hand side, this will be virtual image. If this image is created here, this will be virtual image. If the image is created right hand side, this will be inverted image, and obviously this is real image as well. Okay. Next, the object moves closer to L and the new distance between the L and the object is less than the focal length L. Describe how the new image to be formed. Let's try to understand this one. Now for example, less than focal length. This image right now is here, which is lesser than 3 centimeter. You can see here, right? Same process. I will draw a line like this. That line will pass through this one, correct? And one more line will pass through, one more ray will pass through this one. Can you see this? So it will go like this. At the back it will merge, right? And the image will be created in this side. So obviously it's larger. As I told you right now, if the image is created the left hand side, this will be virtual image, and this will be upright. Okay, right hand side inverted image, and this side upright image. Did you get it what I'm trying to say? So yes, I've written the answer. This will be virtual and upright. Okay. Next, question number 7. Figure 7.1 is scale drawing of light waves approaching narrow slit. So scale drawing is given 4.0 10 meter. This is the direction of the propagation of light. You can see here, right? And name the wave effect produced by the narrow slit. Easy. So this is called diffraction, right? Now using figure 7.1, the wavelength of the light, give answer to significant figure. You can see here, right? If you see this, I think the scale map is given 4.0 times 10 to the negative 7, and 1. See, using the ruler you can check what is the wavelength we have. Using ruler you can check it as 1.2 centimeter. So 1.2 centimeter times this one, because scale map is given. So this is the answer for 2 significant figure. You are getting 4.8 times 10 power negative 7 meter. right? Draw three waveforms that are passed through the narrow slit. Remember this one, okay? If we have, okay, I'm doing this here. If this gap and this gap is nearly equal, right? This gap and this gap is nearly equal, then we can expect this curve like shape. You can see here, right? A curve like propagation of light. You can see a diffraction. Now if the gap is more, you can see here, right? If this gap is more than the wavelength, then you will get a less curve like structure. Do you get what I'm trying to say? But for this case, this gap between the slits and this one is nearly equals, so we are expecting curved, what I can say, the curved lights, right? Diffraction of lights. Okay, so here, yes, we have, as per the question, we have to draw how many lights? I think three waveforms, right? Sorry, three waveforms. So this is the three waveforms I have drawn here. Be careful, this length will be exactly same with this one. Okay, the distance, the wavelength is lambda is given. Okay, next, a foghorn emits a sound with frequency 380 Hz. The sound is heard by a ship that is 2.5 kilometer away from the foghorn. The speed of sound is given 330 meter per second. Show the wavelength of, we need to find out the wavelength. So that is one formula which is related to wavelength, that is V equals to frequency times lambda. And if you rearrange it, this frequency will come here. So V equals to F frequency. So velocity of sound is given 330 meter per second. Frequency is given 380 Hz. And when you type it in the calculator, you get 0.868 up to two significant figure, you are getting 0.9 meter. Please write down the unit of this wavelength, which is exactly distance, right? The meter. Calculate the time taken for the sound to travel to the ship from the foghorn. Time equals to distance over speed. Distance is given 2.5 kilometer, right? Distance given, see, this is given 2.5 kilometer. Speed of light is given meter per second. So here it is kilometer, this is meter. You have to convert this into kilometer to meter. So 2.5 times 1000, that is equals to 1500 meter over 330 meter per second, that equals to 7.5757. After two significant figure, we got time in terms of seconds, 7.6 seconds. Got it, everyone? By the time, please guys, do share the video and subscribe the channel so that you can get regular videos on maths and physics, that to IGCSE, AS and A levels. Okay, right now, next question is about motor. This 8.1 shows a metal rod suspended in a magnetic field produced by a pair of permanent magnets. You can see here, this is two permanent magnets, right? This metal rod is connected to a cell and there is a current in metal rod. Okay, so question is given that state the direction of the force of the metal rod due to the current. Explain and answer. Okay, let's try to understand this question. Before going to this diagrams, listen, this is here we have a battery, right? When this battery indicates that this is all about DC motor, and for DC motor, what we have to use? We have to use left hand Fleming rule, right, to identify the force. See, I have drawn this here also, Fleming, right? Okay, one more thing. Remember, the magnetic field always goes from north to south like this. You can see here, right? Magnetic field is always goes from north to south, right? Now we'll talk about current. Current flow from, always flow from what? Positive to negative. It will pass through like this. You can see here, right? Current flow, right? This is flowing positive to negative like this. You can see here, right? So now left hand Fleming rule says that if, see, this index finger will show the magnetic field, right? This middle finger will show the current, and this downward thumb will determine the force. Definitely your direction of force is downwards. You can see here, right? Correct. So using Fleming hand left hand rule, the magnetic field from left to right and current into the page, and the thumb points downwards. Got it? The cell, the connections to the cell are reversed. State how this affect the force. Obviously, if this, see, if I change it, this one and this one, right? So now the current will flow like this. Correct? The current will flow like this. So definitely the your force will be in opposite direction, that will be upwards. Did you understand, everyone? Yes. Now moving to question number C, 8C. Now two magnets and the cell are used to make a simple electric motor as shown in figure. This is north, this is south, this is the motor we have. Now question is given, describe the function of parts J, K, L and M, right? Yes. See this like black like structure you can see here. They are known as carbon brush. What is the use of carbon brush? Carbon brush is always used to ensure continuous contact between the external circuit and the split ring commutator. See, you have to pause it. You write down the definition or remember this one. Okay, split ring commutator. And what is K here? This K is nothing but is known as coil. This is a coil, right? This is coil. And what does it mean? It is a loop of wire that carries current and complete the circuit. Okay. What is L? L is this one is known as shaft. This L. This is known as shaft. What does it mean? It transfers rotational motion or mechanical energy to the external device, this one. And what is M? M is nothing but it is known as split ring. This one, this M is nothing but split ring. It does what? It does reverses the direction of current every half turn. You remember this, the working of this, all this carbon brush, coil, shaft and split ring. Got it, everyone? Next, question number 9. Strontium 90 is a radioactive isotope of strontium. The nuclide notation of strontium 90 is, what is that? Remember this one. See, if there is an element, this two numbers indicates two different things. This indicates the nucleon and this indicates the number of protons. Okay, this nucleon means this is protons and neutrons, sorry, protons and neutrons. Yes, and this indicates only protons. So what is isotope means? Elements of same proton number but different neutron numbers. Got it? Now in this table, number in one atom is given 38. Outside the nucleus, this is nucleus, right? Outside the nucleus, what we have outside the nucleus, there is always electron. Do you understand? So I have written electron here. Number of electrons is equals to number of protons. So this is 38, this is 38, and this is inside nucleus, means definitely this will be proton, right? And neutron is always present inside the nucleus, and number of neutron is equals to, you can see here, that is 90 is the nucleon. You can see here, right? Proton plus neutron equals to 98. So neutron equals to 90 minus 38 equals to 52. Got it? Yes. 9b. The strontium 90 is used to measure the thickness of metal sheets in industry. Strontium 90 decays by emitting beta particles which passes through the metal sheet to detector, right? One metal sheet is 0.75 mm thick. Suggest why strontium 90 is a suitable radioactive element source to measure the thickness of metal sheets, because we know that beta particles is used to measure the thickness of sheets, right? So this question is given emitted beta particles. So it emits beta particles which can pass through the thin materials like metal sheets. So it is less ionizing than alpha particles as well. This is the use of I think beta particles you can write down, which we have learned in radioactivity. Okay, the half-life of the strontium is approximately 27 years. 27 years means here, for example, this is 27 is the half-life, then 54 will be nearly, this is the half-life, right? So the shape of the decay, this is a decay curve is given, percentage of strontium 90 remaining, and this is as of sample years. Okay, the strontium 90 source is replaced with a new source is after 15 years. After 15 years, okay. Suggest why a strontium 90 source that is more than 15 years old needs to be replaced with a new source. Okay, try to understand this. See, at 15 years, what happens? The remaining portion will be less than 75% of strontium, right? So I can write down here, after 15 years, the activity of strontium, right, had decreased, which is less than 75% significantly. Yes or no? Which means it now emits very few beta particles. So very few beta particles means radiation may become too weak to accurately measure the thickness of the metal sheet. Did you get it right? Okay, moving to next question. This is the question from space. Planets and shows the path of Earth orbits the sun. X is a position on the Earth. You can see here Earth, where scientists observe the apparent motion of sun throughout the year. Determine how many days it takes Earth to move around a orbit from F to G. From F to G. See, it is if you see, this is F, right, and this is where is G, right? Remember, if this is the earth we have, and it goes for a complete revolution, it will take 365 days, right? If you see this, this is exactly the one fourth, this is the one fourth of 365 days, right, from this place to this place. So one fourth of, or one quarter we can say, this is one fourth of 365, means it will take maximum 92 days, right? F to Z is a quarter of the complete orbit earth around the sun, which takes 365 days. Got it? Next part. Figure 10.1 shows that EFGH and of the earth in orbit. So identify the position of the earth where it with summer at X. Okay, it's easy, because if you see this, this is very bright, so definitely this will be in brighter, because that is summer. And winter, this is darker, right? You can see a G, so that will be your darker, means this will be winter. Got it? Next, the orbital speed of the earth around the sun. See, around the sun means orbital speed is the time will be 365 days, approximately 3.0 times 10 power 4 meter per second. So calculate the radius, average radius of the earth orbit. Very simple. There is one formula, find the orbital speed, that is v equals 2 pi over t, but the problem is the t should be in seconds. So the time taken by this earth will be 365 days. You have to convert days to hours, that is 24 hours. 1 hour is 60 minutes and 1 minute is 60 seconds. So in place of time, we have to replace this 365 times 24 times 60 times 60, that days to seconds, right? So v is given 3 times 10 power 4 equals 2 pi, or 2 pi r over this one. We have to keep our subject and everything, you have to take it other side. When you rearrange it, you will get 1.5 times 10 power 11 meter. You can write down in standard form. And yes, the radius, this unit should be in distance unit, that is exactly meter. Earth is a planet in solar system. State one other type of naturally occurring object that is present in solar system. You can write any answer. This is easy. Asteroids, comets, moon and stars. Anyone you can write down, and we can get the answers, right? So please, if you want to download the this worked solution, please go to the website, that is www.mathtonic.com. go to that section is study materials. If you go to study materials, there is a physics, okay, click that, you'll get to download this paper as well as the work solution as well. Okay, I hope you understood. So please do subscribe and share this with your friends, so that they can get regular videos on physics and math regularly. Okay, thank you everyone, thank you.